Okay, in this video, we're going to go ahead and take a look at another one of these multiple angle examples without using any of these trig identities or anything. And we're going to go ahead and find all the solutions, and we're going to find the solutions that are going to be from 0 to 2 pi. I think in the last video I made, I forgot the 0 to 2 pi part. So we're going to be covering it here and just come up with a strategy how to find, again, all solutions and all the solutions from 0, including 0, all the way to 2 pi, not including it. So first thing that we want to do is, like we did in the last video, is that we have this multiple angle, and to make things easier on ourselves, we're going to replace that with a dummy variable. I'm just going to use t, as we often do, and rewrite this thing so it looks like something that we can solve out nicely. Okay, oops. And now I'm going to throw the 3 on the other side, giving us a -3, and divide by 3. That's the in front of the tangent there. And I'm going to get the tangent of t equals a -1. Okay, so where does, if I take the tangent of a particular angle, where is it going to give me a -1? So we got all of these things here. So we're looking where tangent is -1. And we know that it is going to be a 45-degree angle. Okay. Oops. Why did I put an A down there? That's silly. Where it's going to be negative in the second quadrant and in the fourth quadrant. So, because we know that the tangent of 45 degrees is 1, or the tangent of pi over 4 is 1, and so therefore it is going to want to be negative in quadrant 2 or quadrant 4, as we studied before. So the first angle, right, that is going to give us one of our solutions is going to be 3 pi over 4. Okay. Now, this is one of those cases that we're fortunate that it looks like the next one is going to give us, going all the way around here, it looks like it is going to be, let's see, where am I at here? I'm trying to find the colors here. 7 pi over 4, okay? So this angle out there, the whole thing is going to give me 7 pi over 4 going all in that direction. So that said, is that it looks like it's going to hit every pi increments, like we saw in the last videos. So for example, again, it is going to go 3 pi over 4. Then in pi radians, it's going to hit with another solution. Pi more radians, it's going to hit another solution. Pi more radians, it's going to hit with another solution, etc., etc. So the way that we want to write this, at least in the interim, is t is going to equal the first positive solution, 3 pi over 4, plus every increment that it is going to hit or to the next solution, which is going to be pi n. And I'm going to leave that for the moment because we're about to do some algebra with it. We have to switch back in x divided by 3 in for t because we're asked about x. We're not asked about what we made up there. So I got x divided by 3 equals 3 pi over 4 plus pi n. And then we want to multiply the entire thing by 3 in order to get rid of the 3 that's attached to the x. So after using the distributive property, we're going to end up with x equals 9 pi over 4 plus 3 pi n. Okay, and now we can write where n is an integer. Okay, so that is going to take care of the all section. All right, that is our all solution. Now, to go on to this part right here, which is going to be over 0 to 2 pi, what we can do is that we can test values of n and see which ones are going to be included with that guy right there. So we can go test values of n let's start off simple. And let's just test, let's see, n equals 0 is a safe one. So if I test n equals 0 into my equation here that I built that is going to be revealing all the solutions, I get the 0 right here, and that's going to give me 9 pi over 4, which is, yikes, that is going to be too big, because that is going to give me 2 1/4 pi. That's going to be out of the range, out of the domain or the picks, the restrictions there for that guy. So, so that looks like automatically we got to go in the other direction, because if we plug values in that are going to be like n equals 1, n equals 2, we're just going to get larger and larger, and we have no chance to get that into the range or the domain that we need. So let's plug in a -1 and see what shakes loose here. So let's see, we got 3 pi, and now we got this business of a -1. Okay, and just doing out some of the arithmetic. Oop, that's going to be a minus sign, isn't it? Okay. And over 1, I'm going to use that crisscross technique real quick. So I'm going to get 9 pi minus 12 pi. I don't like the looks of that already. We're 4, so that is going to give me, yikes, again, a -3 pi over 4. So over this, if I were to say that's less than 0, so it looks like there is going to be a solution here. For all solutions, we're fine. But over this guy, there are no values that are going to be within that range. So there's going to be no solution over 0 to 2 pi. And so to show that graphically, I just generated a Desmos graph, and I cut off the other one that was going to be over here. But it looks like we have this, and you can see from 0 to 2 pi, we have nothing going on there, because we wanted all the values that were going to generate 0, which is like an x-intercept. We don't have any. So sometimes that happens. So that's how you do that, and test for the values that are going to be over an interval. And next video, we're going to take a look at how to solve things that are going to be too algebraically intense, so we're going to have to use this business of technology. So see you then.